NASA's newest Mars spacecraft, MAVEN, is currently on a mission to determine how Mars lost its early atmosphere, and with it, its water.
The questions that MAVEN is trying to answer deal with the history of the Martian climate. From the previous missions, we have a lot of evidence that that climate has changed over time, that early Mars was warmer, wetter than present-day Mars. What we're trying to answer with MAVEN is, where did all that water go? Where did the carbon dioxide from an early thick atmosphere go? And we're doing this by studying the top of the atmosphere. Since we are the first mission really looking at all pieces of the puzzle on the upper atmosphere, almost everything we're seeing and how it relates to everything else is brand new. As an example, one of the things we measured very early in the mission, right after we went into orbit, before we even got into our final science mapping orbit, was the distribution of hydrogen, oxygen, and carbon as a cloud surrounding the planet, the very extended upper atmosphere.
In this ultraviolet image, carbon and oxygen cling tightly to Mars, while hydrogen, the lightest element, extends well above the planet. Understanding the escape of hydrogen is important because hydrogen is the primary ingredient in water. While previous Mars orbiters have peered down at the planet's surface, MAVEN is spending part of its time gazing at the stars, observing the Martian atmosphere through a series of stellar occultations.
The Imaging Ultraviolet Spectrograph, the IUVS instrument, can determine properties of the upper atmosphere all the way down to the lower atmosphere by looking at a star as the star sets behind the planet as seen from the spacecraft. And by looking at the diminution, the weakening of the starlight as it sets, we can measure the composition of the upper atmosphere.
The relative motion of the stars allows MAVEN to look at columns of the atmosphere, revealing how its composition changes with altitude. At the same time, MAVEN's orbit passes close to the Martian polar caps, giving it north to south coverage of the planet. Mars itself rotates once a day beneath MAVEN, providing east to west coverage. This combination allows MAVEN to observe the entire atmosphere.
My goal with MAVEN is to put together a data set that the Mars science community can spend the next decade or two working on. We're making very few measurements that have never been made at all before at Mars, but what we're doing is we're making them in parts of the atmosphere where they haven't been measured. We're making comprehensive measurements for a full year rather than, for example, with the Viking lander, a one-time entry, one profile. We're going to get hundreds and hundreds of profiles and be able to see how the upper atmosphere responds to the changing solar conditions and really put together a picture of the upper atmosphere that we haven't been able to put together before.